So hello everyone, welcome to this new session. So today's session is going to be very easy and very interesting because this topic circular convolution CC we have already discussed in our previous sessions. Okay, circular convolution step by step problems we have solved. So now nothing much to do. I'm going to give two questions in this session, in this video. And here we are going to solve these two questions using circular convolution, which we have already discussed. Okay, but the method would be different. This time we are going to use the butterfly structure or Dit Fft algorithm. Okay, so this session I won't be taking much long. I'm going to solve it in a very quick manner. Okay, so here this is the first question. These are the two sequences given here, x1 of n and x2 of n. Whenever in case of circular convolution I've told you, right, both the length of the sequences of both the sequences should be the same. So here in this case it is the same, 4 and 4. So we can do the direct circular convolution here using Dit Fft algorithm. What are the steps for circular convolution which I have told? First step is the DFT of the first sequence, DFT of the second sequence, point to point multiplication of both the DFTs. Whatever answer we get, the answers IDFT you should be doing, and that would be our final circular convolution answer. Okay. Then the verification part using the normal general method of circular convolution. So this is clear. So here in this case we are using, instead of DFT, DIT of these two sequences, point to point multiplication. Then whatever answer we get, it's IDIT. Okay. For here the length of the sequence is 4, so we are going to do 4 point DIT. Okay. So now let's solve it quickly. Yeah, so here as you can see I have made two lines here, two separate, because we are going to do 2 times DIT, right, for these two sequences. Okay, so in DIT I have told you, right, the input side the order would be the same, would be shuffled, that is 0, 1, 2, 3. Then in the output side it would be in the orderly manner, that is 0, 1, 2, 3, as you can see. For both these I have written. First sequence is x1 of n, that is 1, 2, 0, 1, that is 1, 2, 0, 1, and second sequence is 1, 3, 3, 1, that is 1, so this is 2, 1, okay, 3, 3, 1, okay. So now let's quickly draw the structure of DIT, that is first is a pair of 2, right, then a pair of 4. Downward arrow -1, and in the input side 1, 1 here, and here it is 1 and -j, right. Similarly draw it here, the same structure, pair of 4 and 2, downward arrow -1, input side, and let's solve now. So here I'm going to directly write here and keep directly writing the answer here, and point to point multiplication answer, that is y of k. Yeah, so now let's solve quickly. 1 plus 0, that is 1. Then we have 0 into 1 into -1 is 0, plus 1, again 1, 2 plus 1, 3, 1 into 1 into -1 plus 2, that is 2 minus 1 is 1. So in the next stage, 1 plus 3 into 1 is 3, so 1 plus 3 is 4, 1 and 1 into -j, that is 1 minus j. So here we have 3 into 1 into -1, that is -3 plus 1, -2, 1 into -j into -1, that is plus j and plus 1, so 1 plus j. So these are our 4 answers, 4, 1 minus j, -2, 1 plus j. So this is our sequence x1 of k, 4, 1 minus j, -2, 1 plus j. Okay, so this is our first sequence x1 of k. Similarly, let's solve for second sequence, that is 1, 3, 3, 1. 1 plus 3 into 1 is 3. that is 4. 3 into 1 into minus 1, minus 3. 1 minus 3 is minus 2. 3 plus 1, 4. Minus 1 plus 3 is 2. Then we have 4 plus 4 into 1 is 4. So 4 plus 4 is 8. Minus 2 and 2 into minus j, that is minus 2j. 4 into minus 1, minus 4 plus 4 is 0. Then we have minus j minus 1 plus j into 2. So plus 2j and minus 2 plus 2. So these are our answers. 8 minus 2 minus 2j, 0 minus 2 plus 2j. 8 minus 2 minus 2j, 0 minus 2 plus 2j. Okay, so these are the two sequences which I have got. Now we should be doing the point to point multiplication. That is, first point with first point multiply. 4 8s are 32. 1 minus j into minus 2 minus 2j. Put it in the calci. 1 minus I into minus 2 minus 2i. That is equal to minus 4. Next is minus 2 into 0, that is 0. 1 plus j into minus 2 plus 2j. So here only I will change. 1 plus I minus 2 plus 2i, that is again minus 4. So this is our answer after the point to point multiplication. So now for this sequence you should be finding the IDIT algorithm. That is the IDIT, that where the sequence would be changed now. Till now we have not seen for a 4-point IDIT, right? So now in this we are going to see now. So now let us see that. Okay, so this is the IDIT sequence. Here in the input side the sequence won't be exchanged, it will be remaining the same in the order. And in the output side it will be changed, that is 0, 1, 2, 3. Okay, yeah. So now let's draw the structure of IDIT. First it is the pair of 4 we should be drawing first. Then pair of 2. Downward arrow minus 1. The values now should be written in the output side, that is this is 1 and here we have plus j, because in the IDFT the matrix is changed, right? The second row and fourth row is exchanged, so we would be getting 1j minus 1 minus j. So here that's why 1 and j. So these two are 1 1. Okay, so this is the structure. So now let's draw, see what are the answers which we get here. 32 plus 0 is 32 only. Then minus 4, that is minus 8. 0 into minus 1, 0, and 32 into 1, again we got 32. Here we have minus 4 into minus 1 plus 4 into j and minus 4. So minus 4 plus 4j. Okay, so these are the 4 values. So now next 32 minus 8, that is 24. Minus 8 minus 1 plus 8 and 32 plus 8 is 40 into 1, again it is 40. 32 and minus 4 plus 4j, right? 32 minus 4 is 28 plus 4j. 28 plus 4j. I've made a mistake here. If somebody has observed it, very good. If those who have not understand what mistake it is, so now I will tell you what mistake I've done here. So here, while solving in a hurry, I've multiplied all these three together. But we should not be doing that, right? What I've told, whatever the answer we get after the addition, that whole answer we should be multiplying with this j. That's one mistake I did here. So minus 4 into minus 1 is plus 4. And here we have minus 4. So 4 minus 4 is 0. 0 into j, that is again 0. So this is not the answer here. The answer here is 0. Okay. Yeah. So that's why here we have 32 plus 0. That is again 32 only. Okay. Yeah. So don't do that mistake, guys. Be very careful while solving. 0 into minus 1, 0 plus 32. Again it is 32. Now here we should be dividing by 4, not 8, because this is a 4-point IDFT, right? So now 24 by 4 is 6, 40 by 4 is 10, 32 by 4 is 8, 32 by 4 is 8. So our final answer, that is x of n is equal to x of 0 is 6, x of 1 is 8, x of 2 is 10, x of 3 is 8. So this is our final answer of circular convolution. You can check this using the normal general method of circular convolution. I have told you, right? That is first sequence, that is what is the first sequence? 1 2 0 1 1 2 0 1 1 2 0 1 1 2 0 1 into the second sequence as it is 1 3 3 1. This we should be multiplying, right? That is 1 into 1 1 plus 3 plus 0 plus 2. Then we have 2 1s are 2, 1 3s are 3, 1 3s are 3 and 0. Then we have 0 plus 6, 2 3s are 6, 3 1s are 3, 1. Then we have 1 0 6 1, right? The answer is 3 plus 2 5 plus 1 is 6, 3 plus 3 6 plus 2 is 8, 6 plus 3 9 plus 1 10, 6 plus 1 plus 1 8. So here we can see that these two answers are same, matching, right? So here we can say that whatever answer we got by doing this Dit Fft algorithm, we have saved time by using this method, and we have solved quickly for this circular convolution. But in the exam, if they mention circular convolution, they would be mentioning even the method, either it is a matrix method, formula method, or Dit Fft algorithm. For circular convolution, it is a sure question for 10 marks they would be asking, okay? Any one method, using any method you should be solving for circular convolution, and also they would be asking to verify. Okay, this is the verification part which I have done. So hope you understood this problem very well. So now similar kind of problem, let's solve it quickly. One more problem is there, let's solve it. Yeah, so I've drawn these structures here, these two. So now let's quickly solve for DFTs. The first sequence is x of n 1 1 1 1. Okay. So here DFTs as a sequence I have written. Inputs are shuffled, outputs are the same for both these things I have written. One is for x of n and h of n. Okay, and I have written this in order to save time. You can also do like this in order to save time. Okay. Then draw the DFT structure, DIT structure. Pairs of 2 and then pairs of 4. Right? Downward arrow -1. Input side 1 1 1 minus j. Okay. Similarly here -1. Input side 1 1. Downward arrow -1 1 minus j. Yeah. Let's solve it now quickly. So the values are 1, so 1 1 1 1, so you can directly write it. Here it is 1 0 1 0 1 0 1 0. Yeah, so now let's solve. 1 plus 1 into 1, that is 2. -1 plus 1 is 0. 1 plus 1 2. -1 plus 1 0. 2 0 2 0. And here 2 plus 2 into 1, that is 4. 2 plus 2 4. 0 and 0 into minus j, it is 0. And 2 into -1, -2 plus 2 is 0. And 0 into -1 and minus j, 0 plus 0 is 0. So these are our 4 values, 4 0 0 0. 4 0 0 0. This is our first sequence, x of k. So let's solve for h of k now. 1 plus 1 2, -1 plus 1 0, 0 0 0 0 0 0. So this is our first thing. 2 plus 0 into 1, that is 2, 0 and 0 into minus j, that is 0, then 0 plus 2, 2, then you have 0 into 0, 0 into minus j minus 1, 0 plus 0, 0. So these are the second values, 2, 0, 2, 0, 2, 0, 2, 0. Hope you understood this. Then do the point to point multiplication. 4 2s are 8, 0 into 0, 0, 0 into anything is 0, 0. Okay, so this is our y of k. So now for this you should be doing the IDIT structure, right? The sequence is 8 0 0 0. Hope you understood this. I'm doing it very quickly, but I hope that this is clear to you all. So now let's solve for IDIT. So this is the IDIT structure where inputs won't be shuffled, it will be the same, outputs would be shuffled. Okay, till now I hope that this is clear till now because we have solved many problems. So here the IDIT structure, first a pair of 4, downward arrow, the line which touches the downward arrow -1, then a pair of 2, -1, then in the output side 1 and plus j, 1, 1. Yeah, so now the values are 8 0 0 0, right? So 8 plus 0 is 8, 0 plus 0 is 0, 0 plus 8 into 1, so 0 plus 8 is 8, 8 ones are 8, then 0 plus 0 is 0 into j is again 0, so 8 0 8 0 we got here. Then 8 plus 0 8, 0 into -1 0, plus 8 8, 8 into 1 8, then we have 8 plus 0 8 again, and 0 into -1 0, plus 8 8 into 1 8. Okay, then we should be dividing all these answers by 4, right? So 8 by 4 is 2. So here our final sequence y of n is equal to 2 comma 2 comma 2 comma 2, because all the values are 2, so I'm not checking for the sequence here. Okay, so this is our final answer for this IDIT problem. So hope this is clear. Okay, so these were the this was a brief description about the DIT FFT algorithm or the radix to FFT algorithm for both DFT sequences as well as IDFT sequences. These butterfly structures we have discussed in brief, and many around 5 to 6 problems we have solved, I guess. Okay, so that's all for this IDFT structure, DIT, IDIT structure, guys. So now before winding this session, I want to introduce you guys with one more important topic. One small topic I'm going to just explain you all. I'm not going to solve it. It is very easy because that topic we need for the next session. What we are going to do next session is about linear filtering. Okay, for that we need one subtopic. We should be knowing that topic, that is linear convolution. So now let's quickly, I'm not taking much time, only 2 minutes. Okay, so now let's discuss about that linear convolution. So now what is this linear convolution here? Linear convolution means nothing much. Here also in this case they would be giving two sequences. Okay, first I would be telling you how to solve the linear convolution kind of problems generally. Okay, let's take one simple two sequences of 2 points, that is one is x of n is 2 comma 1, h of n is 1 comma 2. Okay, yeah, and here they would be giving you at which place the arrow mark, at which value the arrow mark is there. Okay, that you should be looking very carefully. Okay, now let us see how to solve this. For this nothing much to do, draw an L shape like this. Okay, this only I'm doing, explaining it to you all again, I'm just solving again. Okay, so any two sequences, any one sequence you write it here and here, no problem. So here I have written one sequence 2 1 here and 1 2 here. Then wherever the arrowhead is there, point that arrowhead towards that number like this. Then nothing much to do, just multiply. That is 1 2s are 2, 1 1s are 1. Then similarly here 2 2s are 4, 2 1s are 2. Like this you should be doing. Then group it, that is cross across. This is one group, second group, third group, 3 groups. Then nothing much to do, you should be just adding all this whatever is there in these groups. That is, here only 2 is there, so 2 is our first element, comma 4 plus 1 you should be adding, that is 4 plus 1 is 5, comma 2. Okay, then this arrowhead indicates that the arrow mark indicates the 0th term in the set. That is, wherever the arrow mark is there, those two arrow mark if we join, and if we join in which row, in which place it is meeting, right? So here these two arrow marks are meeting at this phase here, okay, where this 2 is our first element. So wherever that arrow mark meets, at that point of the answer you should be marking that arrowhead. So here I have marked it as 2. Suppose let us consider that here in this case the arrowhead is towards, let's change the question and let us see if the arrowhead is here. Well, what happens if the arrowhead is here? So here the arrowhead would be changing and these two would be meeting at this face, right, at this column. That is where the answer here is 4 plus 1, 5. So here at the answer you should be marking the arrowhead towards 5, like that. Similarly, if the arrowhead here is here and here, so here if here it is arrowhead, these two arrowhead would be meeting at this point, so our final answer arrowhead would be here. Okay, so hope this linear convolution part is clear to you all. Okay, in this way we should be solving generally. So one more method is there to solve using DFT and IDFT. Okay, only the first step is there, right? That is only one change, one simple change is there for linear convolution part. Rest all the steps are nothing but the copy of circular convolution only. Till now what you have solved for circular convolution, DFT of two sequences, point-to-point multiplication, IDFT. Only one first step is there, right? That is only one change that I am going to tell you now. So let's see that. So whenever in case of linear convolution, if they ask problems related to linear convolution, keep in mind that the two sequences won't be of the same length. Okay, whenever they ask to perform using linear convolution, the two sequences they won't be giving you of same length. So whenever they won't give the sequence of same length, we should be making those two sequences of same length. Okay, how to make those two sequences of same length is, some would be telling that sir, if you want to make the sequences of same length, just add 2 zeros here, then those two would be of same length. But it is not like that. We have one particular formula for that. That formula is L is equal to L1 plus L2 minus 1, where this L stands for length of the sequence. Okay, L1 that is length of first sequence, L2 length of second sequence, minus 1. That is L is equal to length of first sequence in this case is 3, length of second sequence is 5, right? 5 terms are there, minus 1, that is 8 minus 1, 7. So here we got L as 7. So now what we should be doing is, these two's length we should be making it as 7. That is, in order to make this as 7, we should be adding 4 zeros, right? 0, 0, 0, 0. Then here, in order to make this length as 7, you should be adding 2 zeros, right? Minus 1, 2, 0, 0. Now these two sequences are of same length. Now nothing much to do, then perform the same circular convolution only. Okay, that is DFT of first sequence, DFT of second sequence, point-to-point multiplication, then IDFT of the required result. Okay, so this is one simple for linear convolution part. Okay, I am not doing the problems because I don't have much time. Hope this is clear to you all about how the linear convolution problems should be coming. So please understand this, guys. Okay, I won't be solving any problem related to linear convolution, but this formula we should be remembering for the next session, that is linear filtering. We are discussing two important methods that I'm going to tell you in that session only. So that's all for this session, guys. Like this video, subscribe to our channel, share this playlist to a huge number because this subject is very difficult. Okay, so please share this playlist, all the sessions of mine, share it to everyone. I guarantee you that everybody would be helpful. DSP, everybody would be passed if you see my videos regularly. Okay, so that's all, guys. Like, share, subscribe to our channel. Thank you.